Hello friends, welcome to this video. So today we will be discussing NMTC 2023 problem 1. So this is our junior level, which was for class 9th and 10th. Today was the NMTC exam. So let's start with the question. So we need to find all integers m and n such that the sum of their cubes is equal to the square of their sum. So let's start. We are given that n, so the sum of the cube is m cube plus n cube, and the square of their sum is n plus n whole squared. Now n cube plus n cube equals m plus n times n square minus mn plus n square, right? It's a famous identity. Okay. Now as you can see in this equality, you can either cancel out m plus n or n plus n is 0, right? So if m plus n is 0, then you're like trivially it's done. But suppose m plus n is not 0, right? Then we will get m square minus mn plus n squared equals m plus n, and that is not 0. Now we will try to bound the m plus n sum. Okay? We know that m squared plus n squared is greater than or equals to m plus n whole squared divided by 2. And we also know that mn is less than or equals to m plus n whole squared divided by 4. The basic idea for these two inequalities is that if you expand them out, you will get the basic inequality that m minus n whole squared is greater than or equals to 0. So these two statements are equivalent to this statement, and this is obviously true. So I mean, if you just take a negative sign for this equation, so you get minus mn is greater than or equals to minus of m plus n whole square by 4, because the inequality sign will flip, and then you add the equations, then you get m squared minus mn plus n squared is greater than or equals to m plus n whole square divided by 4. And this inequation is very important because, and we'll mark it star. M squared minus mn plus n squared is m plus n from the given condition. So we have m plus n is greater than or equals to m plus n whole square divided by 4. And now we'll just evaluate this thing. We are given that m, now let's assume that m plus n equals x. And if you just rearrange this, you'll get x squared is less than or equals to 4x. And if you use the wavy curve method, or basically since x times 4 minus x is greater than or equals to 0, it means that x is between 0 and 4. So m plus n sum is between 0 and 4. Now m plus n cannot be 0, right? So we don't take 0, but it can be 1, 2, 3, 4. It cannot be any fraction or any irrational number or any other number other than these, because m and n are integers, right? Obviously. Okay, now let's discuss these 4 cases individually. So first let's start with the easiest case, which is m plus n equal to 4. And why is this the easiest case? Because in this case, if you look m plus n equal to 4 here, then basically you get 4 is greater than or equals to 4. So basically an equality is holding here, and for the equality to hold here, equality should hold here, and that is the equality should hold in both of these things, and hence equality should hold here. So n minus n whole square should be equal to 0. So m should be equal to n, and obviously if the sum is 4, then the numbers are 2 and 2. So that is one of the solution. So we have uncovered 2 solutions, that is m plus n equal to 0 and m equal to n equal to 2. Let's discuss the next few cases. So the next cases are basically a discussion of m plus n equal to 1, 2 and 3, right? Suppose m plus n equals 1. We'll just first try to play around with our original expression. We are given that m plus n equals m squared minus mn plus n squared, right? And we just also write the solutions that we have covered. So m plus n equal to 0, so that is the first solution. So you can just write as m plus n equal to 0, basically 1 minus 1, 2 minus 1, and so on. Second solution is n equal to 2. Now let's see this case. So m plus n, can I write this as m square plus 2mn plus n squared minus 3mn, right? Which is nothing but m plus n whole squared minus 3mn. If you take this equation mod 3, then you will get m plus n whole squared is congruent to m plus n mod 3, right? Now we will check what m plus n values can take. Suppose m plus n equals 1, then 1 square is congruent to 1 mod 3, so it works here. If m plus n equals 2, then you will get 2 squared, which is 4, is congruent to 2 mod 3. So 4 is congruent to mod 3, but 4 then 3 divides 4 minus 2, so 3 divides 2, which is not possible. So m plus n cannot be 2, but if you take m plus n equal to 3, then you get 9 is congruent to 3 mod 3, which is true, right? So it means that we just need to consider the case m equal to 1 and 3. And we really don't need to consider the case for m plus n equal to 2. So let's first discuss the case where m plus n equals 1. So we found that this thing is m plus n whole square minus 3mn. So if you put m plus n equals 1, this is 1 and this is also 1, so they cancel out. So you basically just get 3mn, or basically mn is equals to 0. And since mn is equals to 0, so either m is 0 or n is 0, and accordingly the other is 1. So basically you get m equal to 0, m equal to 1, or n equal to 1, n equal to 0 as the solutions. And then you consider the case when m plus n equals 3, then m plus n, which is 3, equals 3 squared minus 3mn, right? So you can just rearrange this, and you can get mn is equals 3mn equals 6, right? 9 minus 3 is 6, so mn equals 2. So we need to find two numbers such that m plus n equals 3 and mn equals 2. And a very easy way to do that is you find m minus n, the value of m minus n. So we know the identity that m minus n whole squared equals m plus n whole squared minus 4mn. And m plus n whole squared is nothing but 3 squared, and 4mn is 4 times 2. So 9 minus 8 will give 1. So m minus n is basically plus minus 1. And m plus n equals 3. So I mean, if you just take m minus n equal to 1 for the time being, then we add them, you'll get m equal to 2 and n equal to 1. And if you take the other case, which is m plus n equal to 3 and m minus n equal to minus 1, and if you add them, you'll get m equal to 1 and n equal to 2, right? It is very easy to check. And so that is also the fourth solution, that is m equal to 1, n equal to 2, and m equal to 2, n equal to 1. Now we'll just run through a quick check whether all these solutions satisfy, right? So if m plus n equals 0, then it obviously satisfies, because m cube plus n cube is 0 and m plus n whole square is also 0. If m equals n equals 2, then 2 cube plus 2 cube is 16 and 2 plus 2 whole squared is also 16. So that is also satisfying. So I'll just take them. If n equals 0 and n equals 1, then 1 cube plus 0 cube is 1, and 1 squared plus 1 plus 0 whole squared is also 1. So, and same for the other case. So this 3 also satisfies. And if we take them as 1 and 2, 1 cube plus 2 cube is 1 plus 8, which is 9, and 1 plus 2 whole squared is also 9. So this also satisfies. So these are all the solutions that are for the given condition, that satisfy the given condition. So that is the solution to this question. If you want solutions to other NMTC 2023 questions, then please put them in the comment section. Don't forget to like and share the video, subscribe to the channel, and please share this video to all your friends who are maths enthusiasts and who want to prepare for Maths Olympiad. Thank you very much for watching this video.